Welcome everyone to the webinar. Thank you everyone for joining. I'm Ryan Knight. I work for Typesafe as a consultant and trainer. We're really excited about the release of Java 8. It's added a lot of neat new functionality to Java. Oh, my screen just went. We're excited about the release of Java 8. It's added a lot of great features and functionality to Java, lambdas being the big one. For those who aren't familiar with lambdas, lambdas are basically a function that can be used as a method argument. We're also excited about other things. Along with lambdas, they've added functional interfaces that allow you to build new functions. Streams, the new streaming in the collection API, and default methods on interfaces. So there's a lot of new stuff with Java 8. Now, all these really help to build reactive applications. That's what we want to focus on today. To give you an idea of what reactive applications are, today the applications people are building are very different than the applications even a few years ago. And the demands of the end user are very different. The classic example is WhatsApp, very dynamic real-time application. So what users are expecting today is that they always have their data in sync. It's always up to date. They're expecting real-time collaboration, being able to collaborate with someone anywhere in the world in real time. They want instant feedback. If anything changes, if any of their data changes, they expect to see that instantly. People are always connected and always expecting to see their data live. And they also not want to wait. If there's any kind of delay, they'll go on to the next application. Any kind of slow response times, and you'll lose them. So they want this to be very instant, very real time. And to build these type of reactive applications that are very real time and up to date requires a new backend server architecture. And to talk about the fundamental tenets of this architecture, we've created what we call the Reactive Manifesto, which is the 4 key tenets of a reactive application. The first tenet is to be responsive. Being able to respond to users in real time with extremely low latency, a very responsive, up-to-date application. The next part is being resilient. That's being able to build a system that's able to recover at all levels. In any kind of errors, it automatically recovers for you and can just keep going. Being scalable, being able to handle any kind of load, and being able to grow as the user base grows. And then being event-driven, reacting to live data streams. So these are kind of the key tenets of a reactive application that we want to build. And the way we do this, so we're going to talk today about building these reactive applications, first with Play and then with Akka. If you're not familiar with Play is a asynchronous non-blocking web framework. It has a lot of neat features. One of the key features is it's a just hit refresh workflow. It's complete type safety. It's RESTful by default. It's completely stateless. And this makes it very reactive, very easy to scale, very easy to grow. And the neat things about Play is that all of the requests are asynchronous. So we're going to talk a little about that to start off with. To give you an idea of what it means to be reactive, we're going to go over reactive requests, reactive compositions, reactive pushing data up to the client, and being two-way reactive. To give you just a really brief overview of how Play works. Play is like a typical web framework. It has a routing file. The routes declare when you get a request on this URL, I want to call this controller. So if I get a request into the root index, I want to call the index controller. If I get a request into foo, I want to call the foo controller. And so what Play does with these routes is it calls the controller's methods for us. And these controller methods are just basic Java methods. They're a static Java method that get called when the route is hit. So by default, it's a synchronous request. This is useful for something that you don't have to block on. But the user goes to foo, and this is going to return a HTTP 200 OK response. This is a very kind of synchronous request. Well, what we want to do is, obviously, we don't want to be synchronous. We want to be very reactive and non-blocking. So the traditional way of doing a web framework was to block. So when the requests would come in from the client to the server, we block on that request. And then any requests that would go from the server back out to if we call any backend services, those would block. What we want to do is make this all very reactive and non-blocking. So we want the call from the client into the server to be non-blocking, and any calls the server makes out to other services to be non-blocking. And Play does all of this by default. So what Play does underneath the covers is all requests are asynchronous. So in this example, this is an example of how you can build an asynchronous request. What this does is it creates a promise of a response. What a promise is it's basically saying we want to create a future event that's going to be called in the future. It's going to be spawned off in a thread, and we're going to promise a result that comes back. So in this example, this is a promise of a simple promise that's going to return an HTTP 200 OK response. And this is using the new Java 8 Lambda syntax. They're having an anonymous inner function that when that promise completes, it's just completing with the result. So this is a control that handles a request which is completely asynchronous. So when this request comes in from the client, it's not going to block. It's going to be completely non-blocking and asynchronous. So now to build on this, we can do something even more with this. So to be truly reactive, you need to have something to not block on. So for example, we have this long-running calculation. Say, for example, we want to spin off a thread in the background that processes this calculation and do the calculation on a separate thread. So what we do inside of our request is we have a basic request that comes in. Well, you're going to create a promise of a result that's going to spin off that calculation in the background. And when that promise comes back, we want to map that promise into a new result. Here we're saying when the promise completes, we want to map the result. So in other words, we want to take the result that comes back from that promise, which is an integer, and map it to an OK, HTTP 200 OK result. So that's a one-way asynchronous. Now what we can do is we can build on that even more. We can make two-chain reactive requests. So we have the client to the server. It's completely non-blocking and asynchronous. Now we also want to make a asynchronous request out to a web service URL. So in this example, we're just calling out to the typesafe.com. And here we're creating this web service request. We're calling it .get. So the .get doesn't block, but what it does is instead it returns a handle to something that will in the future have a response. So what we're saying here is basically go out and get this URL, run this request in the background in a separate thread, and when the response comes back, we want to map this response to a result. So what this is doing is this is completely not blocking from client into the server and from the server out to the web service call. So we're having a completely asynchronous and not blocking in two directions. The call coming in and the call going out. So when this response gets back, it completes this request with a response to the client, sending it back the HTTP 200 OK result. What gets really interesting is that with these promise of responses, you can compose them together. What composing means is combining multiple responses, putting them together, and creating a single response back out to the client. So here we're creating two web service requests, creating two promises. We're going out to Twitter and we're going out to Typesafe. Both of those are going to be run in the background in two separate threads. And when those responses come back, we're going to map those responses together, combine them together into one response. So we're going to combine the Twitter website with the Typesafe website, and it's going to be one response that's going to be mapped into a single response back out to the user. So in this example, there's three requests. There's the client into the server, which is completely non-blocking, and then two requests going out that are non-blocking. So all of this is asynchronous and non-blocking. And what Java 8 makes really nice about this is you can see here in the typesafe.map, right, we're using the new Java 8 Lambda syntax. And what this makes really nice is that instead of having to use anonymous inner classes and some other clunky syntax we've had to use in the past, with Java 8 Lambdas, we can simply put the function right inside of the method and make it part of the method call. So we're saying, you know, when we get this response back from Typesafe, then do this, you know, this is the function we want to complete. This is how we want to complete that function. Next thing we can do to be reactive is we can do server-side events. Server-side events are a way for the server to push data up to the client. So this is a reactive push. So here we are creating an event source. Once that event source gets connected, we want to send data up to the client. And so what the client is going to do is it's going to create an event source, and when it receives a message, it's going to display it. And so this will allow this is a very reactive push type of application where we're pushing data in real time up to the client. And you know, this way we can do something like this to react to like a Twitter stream and push event data up in real time up to the client. So this is a one-way reactive because this is only pushing data up. We can also be two-way reactive using WebSockets. So with WebSockets, you've got bidirectional push, and that's the biggest difference between the WebSockets and server-side events is WebSockets are bidirectional. So this means that a client can send data down to the server, and the server can send data back up. So here we have a Java controller with a Java 8 method reference. What we're saying is we're going to create the WebSocket. When it's ready, we're going to create an input that's going to be the data in, and then output is the data back out to the client. This is a simple echo example. So when we get a message in from the client, what we want to do is we want to write that back out. So we're using the Java 8 lambda method reference syntax. So this is basically calling the write on the out. And that's just going to basically just write the data back out. On the client side, all we have to do is connect to the WebSocket, and then we can push the messages out. And when we get the data back, it's going to send it back. It's going to display it. Now I'm going to turn the time over to Bjorn, who's going to talk about being reactive with Akka.
So I'm going to talk about reactive applications with Akka. So for those of you who don't know what Akka is, so it's a toolkit for writing actor-based applications, basically. And I'm going to quickly go over what's good about actors. So it's actor-based, and it's highly concurrent, asynchronous, distributable, and it also scales up and out. And this comes from the fact that actors have a couple of interesting properties. They are message-based, so you can only send messages to an actor and get messages out of an actor. There is no blocking on the actor itself. Of course, that means also that they're event-driven. The messages can be seen as events that you receive inside the actor. This gives you a very sane concurrency model because inside the actor, everything is sort of single-threaded. You don't have to be worried that someone else will look at your internal state and modify it from under your feet. The only way to communicate with the actor is by sending in messages and receiving replies.
Bjorn, this is Laura. Can I just interrupt you really quickly? Would you mind speaking up just a little bit? I think some people are having a difficult time hearing.
Okay.
Thank you.
So, and as is evident, it has a non-request-based life cycle, and that means that it's not tied to the web requests at all. The actors live their own life as entities on the side. And it also has isolated failure handling. It's called supervision. So every actor has some other actor that looks after it. So if your actor fails for some reason, throws an exception, someone else will decide what happens to that actor. So, and the cool thing with Java 8 and the lambda syntax is that we can now more easily sort of define the behavior of that actor by using lambdas. So here we have, in a Typesafe way, a small actor that's called the greeter. He can basically receive two different messages here. It's a who to greet message, and it's a greet message. And this receive builder here sort of builds up a matcher that will, if it's a who to greet message, then it will run the lambda here. And this is all type safe, so we know exactly that this has the who to greet type, and we can reference it right off. And actors, the way that actors are very fit for being reactive is that you can easily hand off work. You can easily create new actors, and they're very cheap to create. So in this example here we basically have a long-running and or dangerous computation going on. And when we receive the hello message, we basically just create a new anonymous actor that does the computation. Here it is not that interesting, it's a two uppercase, but we hand off the computation, and since we here take the worker and forward our message to him, when he replies to the sender, it will be the original sender of the message. So we can basically just forward messages to actors and they will reply to the original sender. The original sender of the message don't have to know that it's not us doing the computation. So you can keep your actor responsive by handing off work to workers or sub actors. And supervision, that's basically where you sort of, if your actor does something that's dangerous and he throws an exception, then the super actor or parent of that actor will decide what happens. And also the Java 8 lambdas make this syntax much nicer, where you can basically match on the type, and then we have the exception with that type, and we can decide what to do. Right here in this example, we really don't use that type in any interesting way, but you can easily write code that's very readable for seeing what kind of action will be taken with a child actor when it fails. Actors can also change behavior. That's a fundamental part of actors, that when you receive a message, you sort of decide that the coming messages will be handled in some different way. And this is basically what happens here. If we get a swap message into this actor, then we say hi, and then we go into another mode where we basically give the actor a new behavior. And here we say that we should become, this is the whole block, we should become the inner behavior here. And this is the new behavior. That basically, when it receives a swap message, it will log another message called ho, and then will unbecome. That basically goes back to the previous behavior on the behavior stack. So you can add behaviors onto the actor's behavior stack and then just pop them off. Okay. This is a very powerful abstraction for handling states or going through a protocol of interactions. So since going through protocols of or other kinds of interactions is a fundamental thing, so there's also a DSL for defining finite state machines. And that's basically when you have a fixed number of states and define transitions between those states or behaviors. And it's usually used to model, for example, protocols or processes. You might have a business process that says, go out, fetch this, get a few answers, go to the next state, and so on. And this is also something that you can define really nicely with the lambdas. You get a really readable DSL here. That this is a guy. It's called a buncher. This abstract FSM, finite state machine. He basically gets messages, and he will send them out in a batch, either after a fixed time or when he gets a flush message. So we say that he should start in the idle state, and he's initialized. And when he's idle, if someone sends him a set target message, then we will set the receiver of the buffered messages by staying in the idle state and changing the data to set a new set target. And when he's in the active state, we wait for a maximum of 1 second, or either we get a flush message or a state timeout. The 1 second has expired, and then we will basically go back to idle and empty the list of messages to send. The sending of the messages, that is handled on the transition from the states, basically. So we'll see that on the next slide. So on the transition between active and idle, we basically take the data and match it. And this is sort of a matcher that depending on the types of the data, we can do different things, but we have a matcher here that we want to reuse later, so we don't create a new one for every transition back and forth. So when we get the data, we will basically send a new batch of the queue to whoever is the target. So that's a small example of sort of using the finite state machine to transition between a couple of states and doing something on the transitions. I also want to briefly mention the interoperability package that's being worked on right now. It's specifically designed for the futures and completion stages in Java 8 and in Scala. So because that's a big part of reactive applications, being able to sort of leverage these. So it's right now you have can seamlessly work with Scala futures from Java. So this is a Scala future basically, where you in this example you get a future of string and then you map that future, and this little func here, that is the converter between a Java, a lambda, and a function one. That's basically what Scala expects. So using this, you can basically all Scala APIs where you get back futures and other things, you can seamlessly work with them from Java. There's also a conversion between Java completion stages and Scala future both ways. So you can have a async Java API where you get back a completion stage. That's part of the Java 8 futures as well. And then you can convert them to Scala futures and then pass them into Scala APIs. And the same way, other way around. You can sort of get back a future from the Scala API and then convert it to a completion stage and pass it into a Java API. And this will sort of allow you to seamlessly interact between these asynchronous APIs on both sides. So tying back to the things that Ryan talked about, this is a small demo of a reactive stocks application with using the Java 8 stuff. And it's an activator template. I don't know if you know activator, otherwise you should, because there are a lot of small interesting templates there that can get you going really fast. It uses Akka actors to sort of model the stateful part, or the session part of the app, where you sort of have a connection from a client through a WebSocket. And it uses the Play framework for reactive composition, push, and JavaScript UI. So I'm gonna try to switch over to this. So this is basically what Activator looks like when you have it running. I have the Reactive Stocks Java 8 tutorial loaded, and you have a nice tutorial here walking you through the application, basically. This is an explanation of the Reactive Manifesto. This is a sort of going over the reactive push part and things like that. So I can just briefly show you what the output of this is. It's running faked stock transactions, because we don't have a feed of stock data somewhere, and you can see trading going on. And then you can basically click on one of the symbols and have it go out to Twitter and analyze a bunch of tweets about that symbol, and the tweets say hold for that stock. Let's see if Apple. Oh, can I fetch the tweets? So it pulls in data through a service and does some text analysis of it, and you can add stocks and different things, and they're all running independently of each other through WebSockets. So yeah, couldn't fetch the tweets. But anyway, this is basically the application. You can easily download it and play with it yourself. I just wanted to sort of show a few things here. This is a user actor, and it sort of takes care of the communication between the WebSocket and the stock actors. So for each user and WebSocket connection, you have one of these actors behind the scenes doing the work. And here you see the receive block, and it can either get a stock update or it can get a stock history, and that's what it sort of responds to. And going further, it will describe how you do how you write your pages in Play, and also the JavaScript part of rendering the output from the WebSocket. So yeah, I'm not going to go into too much detail here. It's actually, I think it's better for you to walk through the tutorial and look at the code itself. It's very self-explanatory, and yeah, it's a really nice tool. So here are a number of activator templates for all the things we've been talking about today. It's simple hello Akka and Go Reactive with Java 8 and Play framework, picking up on what Ryan said. We have supervision, how you handle failures in your actors. We have finite state machines, where you basically have the same sample of actors going through states with both just become and unbecome, and with the FSM domain-specific language. There are also a number of samples if you want to start using Akka persistence, which we had another webinar on, which is a great feature for command sourcing or event sourcing your actors or your state. You can look at that as well. And then there's of course the reactive stocks sample that I just showed you briefly here. So that's it for us, I guess. So it's over to you and Q&A.
Thank you so much, Bjorn. I'm going to go through some of the questions here. If you have any that you would like to submit, feel free to do so. Let's see here. We have quite a few. So this question says, what specific changes will Scala make based on Java 8? Bjorn, do you want to take that, or I could hand it over to Ryan as well?
I didn't really catch the questions at the beginning.
What changes will Scala make based on Java 8?
Okay, so I don't think Scala as a language will do any changes. We have the interoperability package where we try to make the integration seamless. What will happen going forward, though, is that Scala will start using the added features in the JVM for supporting lambdas and stuff to generate much faster or better bytecode. So that's the direction we will take. Obviously, we'll sort of look at stuff and try to sort of yeah, and not clash with Java 8 stuff, but yeah, we're trying to make it through an interoperability library, basically. I don't think Scala as a language will change.
Great.
In that direction.
This question is with regards to reactive composition. How does a request that spawns a thread scale? The example given is if you are hit by 10,000 requests, how does that spawn 10,000 threads? Are you still doing context switches between those 10,000 threads? I might switch this back over to Ryan. Ryan, if you want to take this. I think you're unmuted.
Yeah. So if you have 10,000 requests, that is not going to spin off 10,000 threads. And that's the whole idea of being non-blocking and asynchronous, is that when those requests come in, you can basically suspend that request. You can then go on and use that thread for another request. So 10,000 requests could actually be handled with 5,000 threads, for example. I'm sorry, not 5,000, with several hundred threads. Because what you could be doing is you could basically have this thread pool that's handling the request. So as each request comes in, you bring the request in, you suspend it, and then you basically put it, you can go off and do processing in the background and handle new requests with those same threads. So it allows the number of requests that are handled can be much larger than the number of threads.
Great. Thanks, Ryan. The next question is the receive builder available in Akka 2.2, or does it come out in Akka 2.3? Bjorn, do you want to address that?
Yeah, so the receive builder and the whole Java 8 interoperability is for 2.3. It's on the side, but we had to do some changes to the actor interfaces and the finite state machines and something. So it's not couldn't be binary backwards compatible and come out for 2.2.
Great, thank you. This question is about Activator. So, and I'm going to give it to you, Ryan. If I downloaded Play Activator a couple weeks ago to start using these new features, would I need to upgrade Activator or Java or Scala? Ryan, could you address that?
Yeah, you don't need to upgrade Activator. You just need to upgrade to Java 8. Yeah, and you don't need to. And if you're just trying to get the Java samples to work, you won't need to upgrade. Yeah, you just need to install the latest version of Java. I don't know if there's anything Bjorn wants to add to that. He might have something to add. This is just upgrading Java 8, though.
Yeah, absolutely. You know, just if you want to go with the Java 8 samples, you just need to run with the Java 8 JVM, because Activator will sort of look at the launcher if it's up to date and can handle the templates, and it will actually auto upgrade the launcher if it needs to. So yeah, it shouldn't be a problem at all.
Great, thank you. The next question is about Play 2. Hello, Play 2 framework, as you say, is stateless. What if I want to maintain little state, like a shopping cart? What are suggested practices for storing state if required? Ryan, do you think you could address that?
Yeah, there's a lot of ways of addressing it. If it's a very small state, right, you can use cookies. Right, in a cookie, you obviously don't want to put too much state. You want to be very lightweight because that's cookies sent with every request. What else you can do is you can have like a session ID, and you can look up state in something like a React or a NoSQL database. So you can have a state stored off of the server, and that way that allows you to basically scale horizontally, so it doesn't matter where the request is coming in. The request can come into any Play server, and then you look up the state for that particular user in like a shared cache. It could be like any kind of like distributed cache, like like a React or a Mongo. So there's a lot of ways of doing that. You're basically looking it up via the session ID, which is stored in the cookie.
Thanks, Ryan. Yeah.
Right.
The next question is, so the Play team's unfortunately not on the webinar today, but when will Play 2.3, which will include Akka 2.3, be out? Bjorn, are you able to handle that one?
No, I actually don't know their timeline, so unfortunately I can't answer that.
Yeah, Ryan.
Yeah, I don't know either.
A better question for the Play team. We can have them follow up with you directly. So this question is, would it be fair to say Java 8 lambda syntax is coming closer to Scala syntax for Akka and Play? Ryan, you're unmuted, so I'll let you take that if you want to.
Definitely. Yeah, the Java 8 lambda syntax makes it, with the function, it basically adds functions very similar to what Scala has. So it's a much smaller step between Java 8 and Scala. And there's definitely a convergence there. So, yes.
Cool. Let's see. I submitted a lot
And there's also, I'd also add, there's other things in Java 8, like with Java 8, your interfaces, you have interfaces with default methods, static methods, which make the interfaces in Java a lot similar to traits. So like into Scala traits, and so that's another way that Java 8 is becoming more like Scala. And so really, there's similarities are getting smaller. The similarities are getting they're getting a lot similar, and they're kind of moving towards the same direction. So, yeah.
All right, thanks, Ryan. The next question is, are there any samples of AngularJS as client framework and Play REST with Java 8?
No.
Yeah.
It wouldn't be too hard to do. Right, we have AngularJS samples, and really, AngularJS, you can just use JSON data, which is, Play is RESTful by default. It's very easy to return JSON from a Play RESTful service and consume that with Angular. So it would be a pretty small step to take the Angular samples and just convert them to Java 8. What you can do is you basically want to look at the play Java 8 samples that are returning JSON data and just do something very similar to with the Angular samples.
Cool, thanks. The next question I'm going to hand over to Bjorn. What pros and cons in Akka versus event bus of Vertex? Vertex. Bjorn, can you field that question?
Yeah, so I actually haven't worked with Vertex that much. I can only say what Akka is. It's sort of it's a actor model toolkit with supervision built in, and I think that is a very, very important part. I don't know if Vertex does fault tolerance in that way, but Akka is built around the notion of let it crash, where things will go wrong, and you write your applications knowing that actors will fail and they will be restarted. So that's sort of built into the model that you have to think about failure. You can't just write your app for the sunny day and then when it crashes, it takes down the whole system. So that's a really important thing.
Cool. Next question is, how would you recommend monitoring the performance of Akka in Java 8? For example, are transactions that insinuate futures in promise classes going to look like any other class when monitoring a JVM? Bjorn, could you want to take that question?
Yeah, so I really didn't catch the thing. There was something about transactions or, but
sure.
monitoring.
I think the general question is about monitoring the performance of Akka in Java 8.
Yeah, so monitoring an actor system is a bit different that because you have to sort of try to follow the flow of the messages, and we're actively working with tool vendors to sort of enable tracing and monitoring of actor systems in a better way. Of course, you can measure performance like you would any other JVM, but finding the flow of the message through the actor system is a bit different. So yeah, and there's a developer helper or developer plugin, you can say, that's called the console that's used to sort of enable you to look at the trace data as a developer. Yeah, right now we're working with tool vendors to try to ensure that you can do this in a production system as well at a reasonable cost.
Okay, thanks, Bjorn. I'm going to take a couple more questions here, and then we're going to wrap up. Again, if we didn't get to your question, we will follow up directly via email. Hopefully you can get some more detail that way as well. So the next question is, with the new functional additions in Java 8, what would your opinion be the most compelling reasons to pick Scala over Java 8 for reactive applications? Ryan, I don't know if you feel comfortable taking this question.
Bjorn, how about you take this one?
Okay.
Bjorn.
Okay, so they're very similar, or getting more similar, but I still think there are features in Scala that are sort of missing from the functional Java side, as well as the collections in Scala are very, very powerful and have a lot of functionality that you want to have that in part is missing. The Java 8 collections are really good. They're getting, and the streams are getting really usable, but there are still fundamental things missing, I think. And also having traits, real traits, can actually allow you to compose your application in a much better way, I would say. But yeah, that's my opinion.
I don't have anything to add to that. So that's...
Okay, great. Next question.
Yeah, the biggest thing is with Scala, like functions aren't actually. Oh, go ahead.
Oh, you should go ahead.
Yeah, I was just going to say, yeah, with Scala, functions are actually like part of the type system. You can think of them as part of the type system, and so they're really baked into the language. So it's a much tighter integration with functions. And there's a lot of other features beyond functions, like pattern matching, case classes, that add a lot of power to Scala. So we still, there's still a lot of reasons to go to Scala.
Great. The next question is, we have a multiple play framework running, and we're using WebSockets to update client display. If client A opens a WebSocket, it connects to a particular play server. If another play server updates the data, how can client A receive the WebSocket push update? Ryan, do you want to address that, or do you think it's a better question to field over email?
Well, we can briefly address it. The big question is how, like, so server A updates the data, how does server B see it? And that depends on, what kind of backend database you're using. If you're using something like a distributed database, you can actually have it, being pushed data in real time. And so that way you can basically be looking at the data in real time, like through maybe a clustered React instance, and so they can be monitoring for updates and be pushing updates up to your client that way. And we can go into more details in an email if they have further questions.
Okay, great. Yeah, we can follow up directly. And on that note, I think we might wrap things up here. Thank you all for submitting such great questions. If your question was not addressed, like I said, we will be sending you a direct message. And we're going to be emailing out the webinar recording along with a link to the slides. That way you'll have the links to all of the templates that Bjorn presented at the end of his talk. And if you have any questions for our team, please feel free to reach out to us. You can either just email info@typesafe.com. You can email me, laura.masterson@typesafe.com. And we will get back to you as soon as we can. Thanks so much for joining us today, and hope you'll join us on future webinars. Thanks so much. Bye.